Okay, so here's the MIL-1275 board in action. I've got it set up with the power supply. I've got an oscilloscope on the output. I have a digital load uh, connected to the output of it. This is this design has been changed a little bit. It is now a fully interrupted supply, which means it will shut off power to the load during the 100 volt MIL-1275 surge and the 250 volt spike. This board also can handle the minus 250. It has reverse polarity protection, and it will pass the minus 250 volt spike, reverse polarity. The board also has what's called an enable out, EN out, and a fault. The enable out is a open collector output that tells you that the FETs are fully energized, and there's a fault output that tells you that obviously there's a fault and it's been tripped. So I'll put some screenshots of the MIL-1275 waveforms into the video so you understand a little bit better if you're not familiar with it. But this is designed for a 28 volt military aerospace bus. It can go up to 33 volts, some are 36. This one is set to some customers require 36. This device is set for 34 and a half. It can be changed if anybody needs that that cutoff voltage a little bit higher or lower. That can be changed with the feedback resistors. Right now I've got 28 volts going into it. And right now a digital load is hooked up to the output set at half an amp, so we can see that it's drawing half an amp. And on the waveform we can see 28 volts DC output. I have, thanks to Keysight Tech Support, I was able to put a firmware update into this thing because there was a little bit of bug with the list function, but that's been resolved. Thank you, Keysight. I have a list set up in here that will, once I hit the run, it'll supply 28 volts for 3 seconds. It'll then jump up to 100 volts for 50 milliseconds and then go back down to 28 for 3 seconds. And that repeats 5 times, because that's actually the MIL-1275 spec, is that it has to repeat 5 times. It has to pass that surge 5 times. So what we can see here is when I hit the run, and I've got this set to 1 second, it's a long, boom, shuts off. There's that 8 millisecond spike up to the 34 and a half volts, and then it shuts down for a period of time. Actually, that's the length of the time it's the supply is off, and you can see, bam, that it has. Let's see here. All right, and the list is now done. So what I can do is I can actually zoom in here. I can show you that. There's about that time where the, let's see, oh sorry, I keep hitting the wrong button. I love this oscilloscope, but for some reason I just keep hitting the wrong buttons. Cursor, there it is. Okay, so we'll start there. And it's actually a little bit more like into there. 8.6 milliseconds, 8.8 milliseconds, depending on where you want to see that, where you think that that overvoltage starts. It's around 8 to 9 milliseconds. At this load, that's well within the safe operating area of the FET, so everything is good. We're running good here. Let's continue to run. I can run that list again. I think I'm going to have to And I'm going to have to set that out there. And there we go. And it'll do this at full current. This one is set for 2.5 amp maximum output. At 2.5 amps, it'll shut down on overcurrent. And I'll show you that here when this list is complete. All right, list complete. So we're going to change this. Our supply, there's 1.5 amps, 2.5 amps. This one shuts off because of resistor tolerance. It shuts off at 2.49. But you can see at overcurrent, it's shutting it down, retesting, shutting it down, retesting, because my load is continuously over that trip point. So once I go back down to a safe area, it comes back down. Fantastic. That is what it's supposed to do. We'll go back up again. It shuts off. Go back down again. This device can actually, if anyone needs it to be a little bit higher, I've measured this to about 4 amps. At above 4 amps, the FETs start to get pretty warm. And I just don't feel comfortable going above 4 amps on this particular unit. Again, I have a new unit in the works that'll be a fully uninterrupted supply, so it'll actually continue power through that 50 millisecond 100 volt surge and the 250 volt spike. But it requires some beefier circuitry to do that, because you're in that ohmic region of the FETs for quite a while, and you have to have some heat sinking and sturdier FETs to do that. So that is it. This right now it comes in 2 different versions. Honestly, if anybody wants, I can modify this any way people want, but the original design has a high temperature plastic connector if you want to mount this to your board and then connectorize over to it. It also accepts a 0.1 header, so you can put that in there and actually solder it downward onto the board as like a socket, and then hold it down with the screw holes, so standoffs or whatever. That's it. Thank you very much.